Alright, so we'll pick up with section 12.2 on finding arc length. So there's two ways to do this. You can just memorize the formula, but I was never good at memorizing all sorts of formulas. I prefer to understand it. So here is the formula, but I'll show you how this applies in case you don't want to memorize it or you want to understand. Okay, so S means the arc length, which is what we're trying to find. R is the radius. And then this right here is the angle, and it has to be the angle measured in radians, not degrees. Okay, so here is how we can think about this. Okay, let's change that angle into let's change this angle into degrees, just so we have a more intuitive sense. So here's how you do it. We're in radians now, so we want to multiply by 180 over pi. The pi's cancel. 6 goes into that 30 times. It goes into itself once. That's where the 1 comes from. And then 5 times 30 is 150 degrees. So that means this right here is 150 degrees. So the question is this: what's the circumference of that whole circle? All the way around this circle, it's 2 pi times r, which means 2 pi times radius times 6. And that's going to be 12 pi. Okay, but we're not actually going all the way around the circle. We're only going 150 degrees around the circle. So if I asked you what would be the arc length for 180 degrees, 180 is halfway around the circle, so it would be half of 12 pi. Okay, we're not going 180 degrees, we're going 150 degrees. So the question is, what fraction of the circle is that? What fraction is 150 over 360? We'll simplify this. 3 goes into that 5 times, and it goes into that 12 times. So this right here represents 5/12 of the circle. So that means we're traveling 5/12 of 12 pi. If we simplify, sorry, I shouldn't have canceled the pi there. If we simplify the 12s, we get 5 times pi, or 5 pi, and that's the answer. Okay, if you had used a formula, if you prefer to memorize a formula, it's r times theta. So r is 6, and theta is 5 pi over 6. And again, these will cancel, just giving you a 5 pi, which is the same thing we got right here. But again, I think it's a little bit nicer to understand at least where that's coming from. So again, using the formula, r times theta would be 12 times 3 pi over 2. And the 2 will become a 1, and the 2 goes into 12 6 times, and 6 times 3 pi is 18 pi. If you want to do that using the circle example, here's our 12 for the radius. Okay, this right here, when you change it, it turns out to be 270 degrees. So we're being asked to follow. We're being asked, what's the arc length of that arc right there, which is 270 degrees. And 270 degrees out of 360, that's the same as 3/4 of the circle. Okay, so 3/4 of the circle, and that's another way of saying 3/4 of whatever the circumference is. The circumference is 2 pi times 12, which is 24 pi. And 3/4 of 24 pi, when you simplify right here, you get 3 times 6 pi, which is 18 pi. So two different ways to do it. Okay, this one involves, 13 and 14 involve using a graph to find the terminal side, to find the value of the trig function. So this is the point 2 comma 4. So let's draw that point. Puts us right here. Okay. And the question is, what is the secant? Secant is the reciprocal of cosine. So let's just find cosine. And when we do that, we can easily find the secant just by flipping it over. So cosine is equal to, it's SOHCAHTOA, so cosine is adjacent over hypotenuse. And if we look at this right here, well, this point is 0, 0 right here, and this point is 2, 4. So that must mean this x distance, when going from 0 to 2, that must mean that it's 2. And similarly, this y value here, these are the same. Those are both 0, and going up to 4. So it must mean that that's equal to 4. Cosine is adjacent to over hypotenuse, and the hypotenuse right here is going to be, if we use the Pythagorean theorem, it would be 2 squared plus 4 squared. 2 squared is 4, 4 squared is 16, so that's equal to 20. So 20 is the hypotenuse squared, so if you simplify that by taking the radical of both sides, you get hypotenuse is equal to the square root of 20 simplifies to radical 4 times radical 5, which is the same as 2 radical 5. So that is this hypotenuse right here. So that means the cosine is adjacent to over hypotenuse to root 5. The 2's will cancel, so we're left with 1 over root 5. And then if we take that and we flip it over, because secant is the reciprocal of cosine, we would just get radical 5 over 1, or radical 5. Okay, we're in the first quadrant. Remember, the acronym is all students take calculus. Everything is positive in this quadrant, that's why the answer is positive. All right, let's try this one. So the sine of theta is equal to, or sorry, it's at the point negative 10, 15. So let's draw this right here. So let's just say this is negative 10, this is not drawn to scale, that's 15. And we want to, sometimes people forget how to draw the angle. And if you look at the angle is always going to start, just put a point right here, and the angle is always going to be the hypotenuse right there. So it's going to be coming out of this triangle right here. It has to be this one, it can't be this one right here, because we have to have an angle that's touching this axis right here, the x-axis. Alright, so here's our triangle. This distance is going from 0 to negative 10, so that has to be 10. This distance, the leg, is going from 0 up to 15, so it has to be 15. If we use the Pythagorean theorem, that's going to be this thing squared is 10 squared plus 15 squared. 10 squared is 100, 15 squared is 225. So 100 plus 225 is 325, and if we square root this, notice that this ends in 25, so that means 25 goes into that, and it goes into it, turns out 13 times. That's the same as 5 radical 13, so that's our hypotenuse right there, is 5 radical 13. So let's fill this in, 5 radical 13. Okay, now the other thing is, according to this acronym, according to all students take calculus, in this quadrant, sine should be positive. So our final answer, if we do it correctly, should be positive. And the sine is the opposite over the hypotenuse, or 15 over 5 radical 13. The 5 goes into itself once, and it goes into that 3 times. So this is the same as 3 over radical 13. If we rationalize by multiplying the top and the bottom like so, we would get 3 radical 13 over 13. And it turned out to be positive naturally. Like if we had found cosine, we'd have to use a negative 10 instead, because cosine is negative in that quadrant. Because we found sine, it should have been positive. All students take calculus. We're in the second quadrant where sine is positive. So there's our answer. Alright, these right here want us to find the reference angle. So first of all, 470 is more than a complete rotation. That's 360. Okay, to find out how much more, we can just subtract off of 360 from that, and we'll get 110 degrees. So that tells us kind of what the equivalent angle is if we get rid of that extra rotation. So 110, well, that right there is 90. 110 is going to be a little bit more than that. So there's 110. The reference angle is going to be this blue angle that I'm drawing. Takes us to the closest x-axis, which occurs at 180. And the difference between 110 and 180, that is equal to 70 degrees. So the reference angle would be 70 degrees. That's probably not quite drawn to scale, but that's supposed to be 70. And this one's giving us in radians, so it would be easiest to change this into degrees first, just to keep it simple. So that's the same as 180 over pi. The pi's cancel. 4 goes into itself once and into 180 45 times. And then 45 times 11 is 495 degrees. And that's like this problem. We don't want to have that extra distance, so let's subtract out that extra rotation we did, and we'll get 135 degrees. So now that's going to put us in the second quadrant. Here's 90. 135 is a little bit more than that. Okay, and the question is, what is the distance to get us from 135 down here, down to the 180? And that's 180 minus 135, which is 45 degrees. But because we started in radians, it's probably a good idea to put the answer back in radians. So 45 degrees, since I'm in degrees, the pi will go on the top and the degrees on the bottom. And we already know from over here that 45 goes into 184 times. So that's the same thing as pi over 4 radians, which is the answer. Okay, now we're going to use the reference angle to find exact values. So first of all, if we ever see an angle more than 360, let's reduce it so it's something we're more familiar with. So 480 is the same as 120. 120, here's 90. 120 is a little bit more than that. So that means we are looking for this reference angle right here. We're looking for the angle that takes us down to 180. And 180 minus 120 is 60. But remember, we're in the second quadrant, so in the second quadrant, sine is the only thing positive. So this right here is really the equivalent of tangent of 60 degrees, because 120 and 60, they have the same reference angle, but it's negative because we're in this quadrant. We're in the sine quadrant, not the tangent positive quadrant. So negative tan of 60, remember that tangent is the same as sine over cosine. So these ones should have been memorized, sine and cosine of 60 from that table right here. Remember that the sines, we go 30, 45, 60, the sines count up and the cosines count down. So we're dealing with, let's do 1 over 2, root 2 over 2, root 3 over 2. Cosines go root 3 over 2, root 2 over 2, and root 1 over 2, or just 1 over 2. So that means the sine of 60 is this, it's root 3 over 2. Cosine of 60 is 1 over 2. Those will cancel, and we're just left with radical 3, but remember that it's negative. So negative radical 3 should be the same as tan 480, and it is. And remember, they're asking us for the exact value. So if you put this in a calculator, you'll get negative 1.732. That's not an exact value. That's like pi. It goes on forever. So you have to change it, or you have to use the radicals like we did to be able to get the exact value. Okay, secant, whenever we see one of the non-standard ones, like secant, cosecant, or cotan, it's easiest to find the one that goes with it. So cosine and secant are reciprocals. Let's find this, and I'll put a big asterisk to remind ourselves at the end we're going to need to change it by find the reciprocal. So for example, if we find that cosine is 7 over 8, that means secant will be 8 over 7. Let's just remind ourselves at the end to transfer it back. So 315, what does that angle look like? Here's 90, here's 180, here's 270, 315 is about right there. As always, we need to do two things. We need to find out what the reference angle is, and then we're dealing with the fourth quadrant, so cosine is going to be positive, so that's a good thing because we don't have to worry about any changes in positive or negative. So this is the reference angle, the thing that takes us up to 360. And 315 minus, or subtracted from 360 is going to give us a 45 degree reference angle. So cos 350 is the same, 315 I should say, is the same as cos 45. And it's positive because we're in the quadrant 4, which is where cosine is positive. Let's go back to our table. Cos 45 is right there, radical 2 over 2. So one thing we have to remember is that and it's always helpful to look back at the original problem, we were not asked to find cosine, we were asked to find secant. So secant is going to be the reciprocal of that, reciprocal of radical 2 over 2, which is 2 over radical 2. And if we rationalize this denominator right here, we would get 2 radical 2. Rad 2 times rad 2 is just 2, so those cancel, and we're left with the square root, or the radical of 2 as our final answer. Alright, last couple things, we'll do two more from 12.3, and then the next one we'll talk about 12.4, which is the law of sines. So again, we're dealing with, this is a little bit harder, we're dealing with secant, so let's find cosine, and just like in the last problem, we can flip it at the end. And then because we're dealing with radians, it's always more intuitive for people to think in terms of degrees in general. So let's cancel these. 3 goes into itself once, and it goes into that 60 times. 16 times 60 is 960 degrees. So we're being asked to find the cosine of 960, but we don't want to be outside angles of 360. So let's keep subtracting 360. 960 is the same as 600 degrees. We're not in a region that we're familiar with yet. So let's subtract another 360, and we find out that 960 is really like cos 240. It's like 240, but you went around an extra 2 times. So here's 90, here's 180. 240 doesn't take us quite to 270. And I'm going to label this with all students take calculus just to keep in mind what our positive negative should be. So since we're in the third quadrant, we know cosine is going to be negative because only tangent is positive there. And then we want to get back up to the 180, and we're at 240 right now. So that's our reference angles. 240 minus 180 is 60. So cos 240 is the same thing as cos 60, only it's negative because we're in the third quadrant. So that should be negative. So negative cos 60, well, if we go back to our table, cosine of 60, where is that? It's right here. Cosine of 60 is equal to 1/2. So that means cosine of 240 is going to be equal to negative 1/2. Okay, but let's be careful because that's not what our original problem asked. Our original problem asked for secant. So This one is negative 1/2. That means this one is going to be the reciprocal of negative 1/2, which is negative 2 over 1, or just negative 2. And that's our result. All right, last one from 12.3. This one we're going to talk about the cotangent this time. And remember, it's easier to find tangent, so we'll find tangent first, and then we'll just flip it at the end. And we'll change this into degrees, because it's a little bit easier to work in degrees. Those cancel. 6 goes into itself once and into that 30 times, and 30 times 17 is 510. But we want to be between 0 and 360, so let's take away an extra rotation there, and we'll get 150 degrees. So this is the same thing as a tan of 150 degrees. Right, here's our label. All students take calculus. 150, there's 90. 150 will be about right there. And the question is, what's the reference angle that takes us down to the closest x-axis, which is at 180? And the answer would be 180 minus 150, and that turns out to be 30 degrees. However, we're in the second quadrant, only sign is positive there. So tan 150 is like tan of 30, only it's negative. Okay, negative tan of 30, let's go back to our table. Remember, tangent is like sine of over cosine. So there's the sine of 30, there's the cosine of 30, 1/2 over radical 3 over 2. So let's change that. So we have this negative, keep the negative out front because we'll deal with it later. Negative sine 30 over cosine 30. That's the same as negative 1/2 over radical 3 over 2. Those cancel. We're left with negative 1 over radical 3. That's the tangent, but I'm not going to rationalize it because remember that at the beginning we want to find cotangent, so let's just flip this over. And if you flip over negative 1 over radical 3, you just have negative radical 3, and that is the cotangent. So that was section up to 12.3 in a practice test. We might have maybe 1 or 2 more videos. We'll do the law of sines, cosines, and then the second part of the chapter as well.